Test, test. La 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 la.
Just in time.
Hello. Yeah, so like I said, this is a link to a GitHub. It contains all the slides that we're going to talk about, as well as a little getting started with Trigger Mesh project that I made for you guys, if anybody's interested. And I'll bring this back up later in the slides. So about me, my name is Jeff Neff. I'm a software engineer at Trigger Mesh. Hobbies, competitive SPF games, so first-person shooters, decentralized technology, so like Web3 stuff, and traveling and high-performance cars. Doesn't have to be cars, but yeah. So you guys are probably wondering, what is Trigger Mesh? So we'll start off there. Trigger Mesh is an integration platform. It's basically a set of tools that you can use to create integrations. So we see here we have an e-commerce website, mobile applications, point of sale and inventory applications, feeding into Amazon. We have Google PubSub, IBM MQ, and Kafka. And any of these could be talking to any of these. And these are emitting events into Trigger Mesh, and then we're receiving those into consumers or targets, sinks. You're going to hear me refer to those as targets and these as sources. And it's very easy to rewire any of these to come out of any of these and sync into any of these or the ones that are available, right? So basically, we're providing you a platform to easily integrate things. And we run on Kubernetes. So, you know, we're ready for enterprise-grade production, and everything's open source, obviously, right? We wouldn't be here. So some advantages of Trigger Mesh. Everything we do and everything we're going to look at today is through a declarative API. It's written through YAML. If you're familiar with Kubernetes, you'll be very familiar with us. It's architecture agnostic. So we can run on-prem, we can run on cloud, we can run multi-prem. It doesn't matter. Modern architecture, like I said, we're built on Kubernetes. And we have a self-service mindset. So you guys can go to the GitHub. Everything, you know, is open source. It's there for you to build and play with as you see fit. You don't need us to get started building your own stuff. We're built on extensibility, so plug-and-play architecture. You know, if you don't like it, you just plug it out, plug it in, add something, and build your application that way. And open source software. Let's look at some use cases or things that you could do at Trigger Mesh. So here we have IBM MQ going into Amazon Web Services. This is a kind of an interesting one because a lot of people are still tied into legacy architecture, and they have the issue of, hey, we paid a lot of money for this, and we'd like to extend our life cycle on our investment. So with Trigger Mesh, it's easy to take IBM MQ and throw it into not only Amazon, but into any of our sinks or targets. Here we have multi-cloud going into Splunk. So let's say you're running 3, 4, 5 cloud environments, and you want all of this data to be logged in Splunk for easy observability. It's very easy to do that in Trigger Mesh. Reduce integration costs. Instead of going through pricey platforms, not to name anybody, we can do it for free here, right? Create real-time alerts, IoT things, ATMs, anything that needs fast, real-time alerts, great platform for it. Streaming data, running serverless on-prem. Streaming data is basically real-time alerts, but running serverless on-prem, so function of its service environment, basically similar to Amazon Lambda, AWS Lambda. So instead of sending off to Lambda, you can run it locally, basically. So I'd like to talk about how does Trigger Mesh work, or what is it comprised of. Trigger Mesh, the basic building blocks for Trigger Mesh is, as we can see here, is just a couple. An integration, as we refer to it, is a bridge. So a bridge is composed of a combination of these components. And we're going to look at majority of these components now, what they look like, how do you create them, and how to work with them. So we're going to start off with what is a source. A source is a component that generates events. I'm sorry, I'm having a hard time dealing with this mask. So here we have an SQS source. And we can see here the API version. Are we familiar with Kubernetes? Raise your hands. Most of us? Okay, so we're pretty familiar with the YAML manifest then. But I'm still just going to quickly go over it. We're going to see a common factor of API version, kind, metadata, and spec in everything we look at. And this one we see here, we're pulling from the API sources.triggermesh, a kind of SQS source. And then we're going to name this sample. And then here in the spec, we have, just making sure you guys can see, we have various configurable parameters. So we've got an ARN, some receive options or a visibility timeout, some auth parameters, or auths are stored in a Kubernetes secret, and then a sink. Where are we going to send these events to? The sink is a reference. We're referencing broker named default from the API eventing.knative. Any questions before I move on? And you guys feel free to stop me at any point. So what does this source create? We send events through a specification called Cloud Events. Cloud Events are nothing more really than HTTP requests with some special headers. There is an exact specification of that in the working group, CNCF, sorry. What we're looking at here is kind of a prettified version of a cloud event. We can see here some attributes, the content type, the ID source type, and then data. If you've seen HTTP requests, this probably looks pretty familiar for you. If not, that one definitely should. This is creating a cloud event through a curl request, or a curl command, I'm sorry. And this is the minimum requirements for a cloud event. So we can see it's a post request, and it contains an ID, a spec version, a type, and a source. It's content type, and then some data, right? So now that we have our events, or we know how they're made and what they look like, how do we consume them? We consume them through targets, or we call them, which are consumers, sinks. There's a couple commonly referenced names. We're looking at, again, the SQS. And we can see we're pulling from a different API now, targets.triggermesh. And then in the spec, it looks pretty familiar. We're just missing the sink because this one's not going to emit events, right? We're just consuming them. And we can think, if we linked the SQS source to the SQS target and it gave it the same queue, we'd basically be making a loop, right? Cool. So now, on that same note, how do we tell the source that we want that event when we're working with a broker? Which we'll go over what a broker is on the next slide. Actually, I think these are out of order. We need to talk about this first. So a broker provides a discoverable endpoint for event ingress. Basically, his job is to take events and then know who to send these events to, and then make sure those people get those events. How the broker knows what events to send who is through triggers, which we'll look at. The TLDR here is a broker's event delivery transport. Okay? So we go back to triggers. So the trigger is how we tell the broker who wants what. Okay? So if we look here, we have a trigger, and this is saying, okay, send all of the events to the AWS SQS target example test named example target from the API version targets.triggermesh that matches the event type io.triggermesh example from the broker default. Okay? So this provides a way for us to do simple filtering, or we could just omit the filter and send all the events. Well, you own the broker, and the broker could be Kafka, it could be PubSub, I'm sorry. Right. Well, if you're allowed to talk to the broker, yes, sir. No, it's okay. So a common issue when we're trying to make things talk that don't normally talk to each other is data transformation, right? Or even things that would natively talk to each other, maybe we want to insert some business logic in there before they talk to each other. So Trigger Mesh exposes components that make the majority of these transformation situations easy. We do that both through exposing function-based components and declarative language-based components. And we'll look at examples of both of these. So a declarative language component basically enables us, we're going to look at these in detail, but basically this enables us to store the properties that we care about. So destructure the object into variables, remove the pre-existing event that came in, or we could keep it, but here we're removing it. And then here we can restructure the event as we see fit. Here we're adding a object provider with a property name. We're hard-coding that core Oracle Cloud infrastructure. And then here, provider.account ID, and we're assigning that variable account ID, which we've pulled in from data.additionaldetails.tenant ID from the incoming event, right? Does that make sense? Cool. And then now we can also do function-based. So in several different languages, we expose function-based components. This enables you to write, insert logic in your favorite language without having to compile a container. It can just be in the bridge manifest, right? So it's easy if you have to just remap something or a quick little function, instead of having to build that entire container and then you just have this little service manifest. It's not descriptive. It can be all in that one manifest, which we'll look at. So this is a node. Here's an example of Python. It's very similar. Basically, we've just changed the runtime, and then the code is Python, right? And then I have one more example here in Ruby. Trigger Mesh also makes it really easy to bring your own services. So if the targets or the sources or transformations that we expose don't meet your needs, you can bring any system or language that can accept or receive HTTP events and can be Dockerized. So not a lot of requirements there. That meets most, right? In Tech Preview, we also have a meta controller that transforms containers into API objects. In English, that means that you can take your containers and with a very small, simple manifest, you can use Kobe to create addressable services without having to write your own Kubernetes controller. So, questions? Okay, so now bringing it all together, what we have here is pretty much the simplest bridge you can make. We don't have a broker or trigger or anything. We just have one source syncing directly into a target, and that's it. This is the most I could fit on the slide, to be honest. So yeah, that's why it's so, but we are going to look at a full manifest here in a second. But yeah, so if we look at this though, from the flow.triggermesh API, we have a kind bridge, and in spec we have components here, and then we have an array of objects. So yeah, we know what these two do, right? We're Twilio, if you're not familiar. This is going to emit, Twilio is a service to connect with text messages, and I believe email too, but in this case it's text messages. So when you receive text messages, they would be synced to SQS effectively with this bridge. But let's say we wanted to insert a function, we just insert the object here, change the sync to the function and the sync of the function to the target, and that's it. If that makes sense. Yes, sir. In its own container. So each of these objects that we look at run in their own containers. in the namespace that you specify the deployment. Yeah, or a cloud cluster. It could be our SaaS. It doesn't matter. We're going to look at an example building in Docker Desktop, a Kubernetes cluster, and we're going to apply some stuff. If that doesn't answer your question, then bring it back up, please. Anyone else? Okay. So just 2 quick case studies. A security group came to us, CSNF. They're comprised of several cloud providers and a group of security professionals. And they have basically created a JSON schema and gotten everybody to agree to standardizing security events into one schema, okay? They then wanted to deploy a proof of concept using this schema and standardizing the events, right? Because the idea is to take in from multiple cloud providers, normalize the event, run it through event decoration, enrichment, and then split those events off into both Sentinel and Splunk. But they also don't want to be married to Sentinel, so they wanted the platform to be, you know, what's your SIM SOAR? What are your cloud environments? With Trigger Mesh, this was really easy. I think this was my project, actually. I think it took me like 2 weeks, a week. Only because we had to add 2 things that we didn't have. Other than that, it was all just wiring and using components, pre-existing components. Yeah.
All those people endorsed this.
Yes, sir.
Security audit and
Well, this is, CSNF is not a complete project. This was a proof of concept. So security audit hasn't been, but it will definitely be done because it is a group comprised completely, almost completely of security professionals, so yeah. And actually, I wanted to show you the full manifest of that. Let me bring it up and pull it over here. So this is the proof of concept. This is going to be a lot, and we're going to go over it quickly, but I just want to show you what does a whole integration look like, right? And we're not using the bridge wrapper. Everything's just cut with the 3 dashes. But anyways, so we have Azure Defender Vents coming in Azure Q Storage. Bumblebee is a transformer. And then those go into Sentinel and then Splunk. They actually split. It doesn't go out of Splunk or Sentinel. Then we have CloudGuard events coming in at Kafka source, normalizing the event, Sentinel Splunk. Aquasec events through PubSub, normalization, and this one gets enriched by a Docker Hub decorator, and then we have Sentinel and Splunk. So this one starts out, we have a broker here, and this manifest is also shared in the GitHub repo. I saw some of you taking pictures, so so we have the broker here, and then we have a debugging trigger here, which basically we see no filter here. This is just so I can see all the events that flow through the bridge, right? Now we have, this is, if you're not familiar with the Kubernetes secret, this is what it looks like. And this is how we define and store our secrets. We're not married to that, but this is a common way that it's done. Now we have a Azure Q Storage source, which should look familiar, but we just, it's Google now instead of Amazon, right? So we have different parameters there. Then we have AWS credentials, AWS SQS source, feeding into, or no, this is one more, Azure Service Bus source. And then now this is, I guess, if it is interesting at all, this is where it gets interesting. Right here in the transformation. So here's a real world example of using the declarative language to remap and restructure these events. So instead of having to write a function that maybe the next guy that I give this function to, he doesn't write the language that I wrote it in. So then he has to rewrite it or whatever, or maybe I don't hand it to a developer. I want to hand this to a security professional. With this, it's very easy to come and look and change the properties that we don't want account ID to be tenant ID anymore. That's fine, we just change it. right? And then we've remapped it. We didn't have to recompile anything. We didn't have to build a Docker container. Nobody had to read any code. So yeah, we're going to breeze through the rest of this because it's pretty much the same thing over and over again. A trigger, bringing Aquasec events into its respective transformation. Yep, it's just taking those events and remapping them to the standard that they had agreed on, right? And then we have another trigger to a transformation. That's going to happen 3 times. And then down here at the very bottom, we're going to see our debugging service, which is just an event display. And then our Google Cloud pub sub source, target, sorry. And then, no, that is a source. I don't think that's supposed to be there. I'm looking for Splunk. Here it is, yeah. Now we have Splunk and we should have Sentinel right above this. Nope, that's Splunk. And here's Sentinel. So from those transformations, they come out. And then you see we're asking for a different event type because once those events go in the transformation, they come out as a different event type. That way we know who wants to grab what. And building this way, it's very easy to extend this by just adding a service that grabs the event type, right? Right, yeah. But if you wanted something else to grab that information, also, you could just deploy him and subscribe him to the same event type. They would both receive that event. Yeah, so I just wanted to show you guys a full manifest. The order they're consumed. So if we go back up to the top. Oh, how? So let's say we have a source and it goes to the broker and 2 people have subscribed to it. They would both receive the event in relatively the same time. The event would be split at the broker and sent to them somewhat simultaneously. Which way am I? There we go. This one, we're not going to look at a broker, and it's going to be, or a bridge. I'm going to keep it really simple. This bank needed to build a modern banking architecture. They needed to integrate with multiple third-party SaaS providers, and they had lots of data streams, event streams that they needed to bring in. So using Trigger Mesh quickly, we were able to incorporate over 180 event streams from 10 cloud-native banking platforms. And it looked something like this mess, which I probably could have cleaned up, but I apologize for that. Okay, so now I wanted to play a little bit. It looks like we still have some time. Let me change my display so that, because I'm not going to be able to type and look at that thing. Okay, cool. So now you guys should be able to see what I see. You can, okay. So going back to here, one more time. Oh, that's not what I'm showing. There we go, there we go. So going back to this, one more time for the GitHub repo, we're going to go into, this is the repo that, oh, I messed you up. There we go. Sorry, guys. If we get it, I think that we're still struggling a little bit on the front. can give you the link too if you. It's just Jeff Neff SCaLE talk notes. So what's in here is a folder called demo. And I made this little guy. It's a trigger mesh quick start. So what's in here is a bash script to spin up trigger mesh on a brand new cluster in Docker Desktop. So your only requirements here is you need Docker Desktop. So probably most people have that. If you don't, it looks like this. It's available on all platforms. And then you need to have Kubernetes enabled. So to do that, we just go here to Settings, Kubernetes, Enable Kubernetes. I didn't do that with you. We're going to do everything else pretty much together. I didn't do this because it's like 15, 20 minutes of us just looking at it spinning, right? But I can show you that it is a brand new cluster. Typing with one hand is interesting. Yeah, it's 9 hours. I just built it this morning, I think. So in this repository, here's the same GitHub repo we're looking at. We have a nice README here. And it's not the one we want. Yes, it is. I was just at the bottom. So if you don't have Docker Desktop, you can install it there. And then we need to enable Kubernetes, which we just did. And then we just run this little script right here. I think I'm in the wrong directory. Yeah. Okay, and what this is going to do is install all of the prerequisites for trigger mesh and spin up the namespaces, all the services, the controllers, everything. You'll have the full production trigger mesh. Well, it's a demo environment, but the production installation ready to go. It takes like, I don't know, 5 minutes. It really depends on your laptop. And then I've also provided here, if we look at next steps, a list of, it's basically kind of like an intro to working with trigger mesh. We start off debugging, then we learn sources, targets, transformations, and I didn't get to these last four, I'm sorry. And this one we're actually going to do together because I thought that would be fun. But yeah, and then here in the trigger mesh components, we have a set of sample bridges. So you can reference these if you're building. And then we have most of, if not all of our components. I'm pretty sure I got them all in here, separated into different folders. So we have debugging, routing, a list of sources, and a list of targets. And what it gives you is so a secret, right? We need this secret, name, key data, password. The name actually is irrelevant. And then how to describe and deploy that target. So this guy is almost done. And what we're going to be looking at is this step one, which is debugging. And we're going to look at how do we create debugging events, and then how do we consume events, right? Because we really can't do anything if we don't understand how to create or how to consume. So what we're going to create here, once our cluster is done, is a ping source object, which is just a dummy eventing or a debugging eventing object. Let me make this a little bigger for you guys. That will emit some data for us on a cron schedule and then send it to sync. And then here we have sockeye, which is just a debugging service that's going to prettify and show us our events, right? So if we open up this guy, we can see here that trigger mesh is done. Took us 2 minutes. And now if we go into this folder, and we apply this file, you have to spell right. We can see that those were created, and then this is if we fetch the pods, I need to make this a little smaller. We can see that sockeye is running here. We won't see a ping source running. He's running, we can, but he's in a different namespace because he's multi-tenant. So multiple people can subscribe for him. He lives in one namespace. But if we go here and we say git ksvc, which is the knative service, this one is set up to expose externally. So we can grab this guy. And then in about a minute, we should see a event come through with the name of trigger mesh. I'm not going to wait that minute. We are, but I'm going to talk about this right here. So the README here is basically what we just did, but then I also provided some working practices so you can start playing with rerouting stuff and extending the bridges, right? And then there's the solution to that working practice there. Come on, bud. There we go. So yeah, this is a cloud event. We just made it. Good job, us. So what do we do from here, right? Step 2, we're going to introduce an actual source. So let's go ahead and clean this up. Okay. So now let's bring in a real source. So we've been looking at the SQS source. Let's use it, right? We're going to need a Kubernetes secret containing AWS access key ID and secret access key. We can see that from here, right? So we're going to need to go get some AWS creds. And then we're going to need an ARN and obviously an SQS queue, right? So let's go do that real quick. Here we have AWS. Let's make a queue. We'll name it SCaLE. And we'll grab the ARN here. Which way was I? This way. Okay. And then we need to go, I'm pretty sure I already did this, but we need to go to IAM. And we need some access keys. I think these are actually already valid right here. These should be good. Let's try these. You guys probably already know how to make access keys, so. You guys can have these too. It's a great account. Big billing cycle. No, it's a demo account. Okay. So now we have our AWS SQS source is wired. Everything's done. And then for sockeye, we have no configurables. So we should be good to go. So let's go into this directory and apply this bridge. Which one was this called? SQS. And this time we will see both pods in the namespace. Get pods, watch. So sockeye is going to spin up first because it's a prerequisite to SQS. We can see SQS is happy. So now, let's refresh this because it's a new deployment. Okay, and so now if we go back to SQS, is somebody already in my Amazon? That would be funny. And we go back to our queues. Did that not create? What happened to it? You guys were here with me when we made it, right? Okay, that's weird. Let's do it again. Yeah, that was weird. Okay. So we're going to need to redo that. And plug in the new ARN. I don't know how I got an ARN if it wasn't created, but oh, good catch, dude. Well, that's okay. We'll use this one because I already deleted it and copied it. Okay. So now if we publish a message, we should expect to see this message at our socket, but I forgot to refresh because I tore it down. Sorry. And Chrome does not like being in. Okay, there we go. Let's do this again. And now we have an SQS message. So here we took it into sockeye. There is an attribute. If we can see the body parameter here, hello SCaLE. There is attributes that our sources provide to, we called it emit cloud event context or emit context. So if we don't want to have all this nasty stuff and we just want to have a body. But yeah, this is, we can see here, AWS Amazon SQS message is the event type. And it came from the source, and here's the ARN that we created it at. So that's cool. Now we've created a source, but let's finish it off, right? We need to go into a real target. So what I thought we would do for step 3, we're going to do a pub/sub source to SQS. So effectively, we're going to sync pub/sub and SQS, right? So we need, we already have, oh, no. That's a source, we need a target. So we come down here, trigger mesh components. Let's start off with the source. We need Google Cloud pub/sub source. So let's look at it. It looks like we're going to need a topic, and we're going to need a service account key, and then we provided a sync. So that's easy, we can do that, right? So pub/sub, we're going to want this guy, and then we're going to need a service account. If you use Google, I'm sure you know how to make a service account. This is another account you guys can have. 2 clouds for free with this cock. That's great. Okay, so we're going to put this service account key in here. And then we're going to need to go make a pub/sub source. So let's go here. And let's go to pub/sub. And I already have one, so let's use that one. But it's just default, nothing special, right? So we need this topic name right here. Okay. And now we're going to have to change this. So let's delete it so we don't forget it. And then we're going to need the target now. So let's go grab from our bin of components, AWS. We're going to need this. We already have a secret, so we don't need that. We'll just reuse our other one. And then we need the SQS target, which we have right here. So let's grab this guy and put him down here. And then we're going to go grab our other AWS key and add him in here. There is a difference. This is uppercase. Why did you do that to me? And this should be called AWS, not AWS creds. Okay, and then now we can go also steal our ARN from earlier. And throw that guy in. And yeah, now we got to do this sync real quick. So we need to grab from the API version. We need this kind. And we need this name. So it's nice doing references, addressable things, having addressable objects, because now I can tear down and replace this SQS target as many times, but this is always going to point to that right addressable, right? If that makes sense. If it's the same name in the same namespace from the same API and kind, then you'll always get it there. So it looks like, no, go away. Looks like we are done here. So let's save that. Yeah, we cleaned up, okay. And let's see if we got it right. So kubectl, apply f, we got pub sub to sqs. Let's see, the pub sub controller was being annoying this morning. He looks happy. So now, we should expect, when we post to Google Cloud PubSub, that we find these messages, whatever we post, in a SQS queue, right? So let's see if we did this right. We go to Messages, Publish Message. Okay, and Publish. And now let's go here and pull for messages. That's cool, we did it right. So if we look here, we may just expand this. This time the data is going to be base 64 encoded. We'll decode it just so you don't have to trust me, but there we go. Hello SCaLE there, so that's cool. That's just we didn't do that, that's just how we get it. And the way we make sources is we try not to have an opinion. If it emits data, Google emits data in a certain structure, we give you that in that structure. We're not gonna make you learn some arbitrary structure that we made up, right? So this is how it's provided and this is how we move it along. So yeah, that pretty much wraps up what I have. I wanted to do these other steps, but I didn't think we would have time anyways. And we got 20 minutes, but do you guys have questions? Yes, sir. Yeah, so functions look like this. We have a couple right here. So if we wanted, you're saying if we wanted to throw a function in here, how do we do it? Well, this is, boom, okay. And now effectively, well, we have one more thing to change. We need to do this. Okay. And now this guy returns it, so we have to use a broker actually for this guy. But we could grab this one. I think all of these actually are meant to be built with a broker. No, this guy should have a sync property actually. Yeah, he does. So let's do that. It's better, we didn't build with a broker, but it's better to build with a broker because the broker provides guaranteed delivery. It also can provide dead later syncs. So what we've been doing is syncing directly from a source to a target. When you go through a broker, the broker, depending on what broker you use, can provide a persistence layer. And then it also provides insurance that you got the message, that the subscriber got the message, and if it didn't, you configure a dead letter queue so you can view the events that were not delivered for whatever reason. That's why most of our components are designed to work that way. But anyways, so here we go. Let's undo that, and then get rid of, we're just going to do one here. I don't know why it has this one. I don't want that one. Oh, this is an example of all of them. That's why. Context store. Yeah, this is a horrible example. Let's go grab a better starting point. I grabbed that from the docs. and that one is not a good one. So let's go grab a better one. Birthday cake, manifest. Okay. This one I know works. Sorry for that. I didn't test every component because I added 500 of them, so. And we only want one property. Okay, and then let me put this here for my OCD. Okay, and so now we have to change this back, our sync, because we changed it again. My fault. And then this guy, did we look at the, yeah, we did. So this data looks like this. So let's just take, let's take data, data.data. Data. Okay, that's what we want, and we don't want it to be that. And then we'll clear it, and then we will say we're going to make a key of hello, and we're going to map that to that data property or variable that we created. And then we're going to rename the event type to trigger mesh scale. Okay. Which we don't actually have to do because we're not using a broker, but. Okay, and then we need this to go here. So let's change our reference. I'm pretty sure that I have this controller should be here. Stop. Did we tear that one down? I can't remember. I don't think we did. No, we didn't. Let's tear it down and redo it. Okay, so if we did this right, which I think I did, I'm not 100% on the data.data, but I'm pretty sure that's the right property. So if we did this right, we should expect when we post to a Google Cloud Pub subsource, it will go through the transformation as denoted by the sync. And then when it comes out of the transformation, it should go to our SQS target. So let's give it a try. Publish message. Hello? No, we put a hello in there. Let's do a goodbye. Nobody ever says goodbye. Okay. So let's see. I didn't even check if the pod spun up. Well, everybody's there, so that's a good sign. 48. I did get that wrong. I knew I was going to miss something. That's okay. We did go through the transformation. I just got the property wrong. So I think it should be, I swear I looked at it right though. Data. It should be, unless it's just data. Hello, data. Okay, let's try that. Let's just try data. There we go. Send one more of these bad guys off. That's going to be confusing. See, I hope I got it right because I did not. No, that's PubSub. Yeah, I don't know why I can't grab that property, to be honest with you, bud. I think I would have to grab that raw to make sure. Let's try data.id just for fun, and then I'm done. ID. Yeah, now I'm going to get lost. Which ones? It's got to be that one, right? Yeah, I'm failing here, dude. I got something wrong. Yeah. There's like just some zero where there's supposed to be a one. But this is how you add it, right? We just plug the component in, reroute how we're routing things. Right now we're not using a broker. So we just go right into the transformation. And then out of the transformation, we go into the target. And that's it. Yeah, that's going to bug me. I guarantee you if that's going to work in 5 minutes when I'm done. Yes, sir.
I saw you have runtime like with Python. Do you have one for binary object?
Oh, like where you would compile an executable and it would just run it?
Execute that, because I don't want it here.
That's interesting. No, and I've never considered that. But maybe soon. Yeah, I would have to think about the implications of that one. But good question. We don't expose that, no sir. Any more? If not, I'm gonna wrap up. Well, thank you guys. I appreciate your time.
All right, so I'm gonna go ahead and get started. If anybody needs to grab any coffee or tea, Secret it's in that room over there. Otherwise, we're gonna go ahead and, yeah, definitely go grab it. They're still in there. They also have a box of Randy's donuts, I noticed. I saw it with my eye. I saw some dude eating it, and I was like, that looks tasty. Maybe after. I'll debate after this, you know? All right, so we're going to start off with unlocking value from time series data with open source tooling. So my name is Zoe Steinkamp. I'm a developer advocate at Influx Data. We are the leading time series database platform. So as I just said, I'm a developer advocate. Before I became a dev advocate, I was a front-end software engineer for about 7 years, mainly working in Angular and React. And then eventually I realized that this was a little bit more fun and interactive with other people. As a developer, you kind of get siloed into your team and don't ever talk to anyone else. I wanted to do a little bit more. So the session agenda today is going to be a lot of overviews. It's going to be an Influx Data overview. So that's going to just kind of talk about, like, why do you need a time series DB in general? What does it do? What's the difference? An actual overview of our platform and how it works. I'm going to do a demo on our cloud platform. Because in general, just, harassing everybody with slides can get a little boring, and it's going to be a little bit more interactive and fun to show you when things don't work. Influx Db and AWS, how we work together. Yes, we're on the cloud marketplace, but there is more to the relationship than just that. And one of our newer things that we've released, which is Influx Db at the edge. So for those of you who are not aware, edge, for our definition, is a device that occasionally has interconnectivity issues with the internet. Finally, questions, resource, and action items. One action item is also, at the end, I'll re-announce this, but anybody who asks a question gets some awesome socks. Got a whole pack over here. And if I have extras, you can just grab them. I don't want to take them home. So, Influx Data is where developers build IoT, real-time analytics, and cloud applications. Marketing. Influx Data at a glance. So we were founded in 2013. Our HQ was in San Francisco before COVID killed it. We were always a pretty much fully remote company. People would come in for free lunch on Thursday and otherwise not show up to the office. But that's where our CEO hangs out. Our founder is in New York, though, so just to clarify, they like to feud about it. We build where developers build real-time applications. What that basically means is when you are dealing with real-time data, we're sitting there with you. That's what we focus on. We are one platform. So one API across multiple clouds and on-prem. I'll go into that in a little bit. Just some quick fun numbers. We have over 1,300 customers and about 600,000 daily active open source deployments. Those are a few of our customer names, some of the bigger ones. We are a PLG-driven usage and subscription model. People always like to ask when we're open source, how do you make money and how will you not die as a company? That's how we are going to make money and not die. So the rise of time series. So pay users, basically. I'm trying to remember what this actually stands for now that you just mentioned it. It's basically people who pay us for usage. Like, that is how we make money, is on the cloud platform. You pay us as you go and you use. It should just be called pay as you go. I actually don't know why it's, yeah, pay large go. So the rise of time series. So here's a good little comparison between different databases. Obviously, one big thing to note about databases and time series databases as well is we are less a competitor of other things as much as we are a complement for that specific data type. You are not going to store your records that you would store in a SQL database into us. It doesn't make sense. It's going to be a very bad experience for all of us. But sometimes you are storing your time series data in SQL and you find out because it gets very large, unruly, and angry. And that's where we come in. We are specifically focused on events, metrics, timestamp data. I always like to talk about IoT devices as a really great example of this. They're super noisy. They send you data almost every single millisecond. That gets very, very big, very, very fast. You want to monitor them on a real time. You do not want to know that your IoT device crashed 3 days ago. That's not helpful to you. You want to know it crashed right now. And at that same note, you also sometimes want to downsample your historical data, which isn't common in other DBs. Normally you want to store things, for the long term. But in a time series database, sometimes you kind of want to not do that. You want to be like, okay, I monitored this today. It didn't break, whatever. I'm going to go ahead and aggregate this down to just give me all these data points by the day or by the hour. So I'm not storing this super finite data. And sometimes you just want to drop it all together. It's just like, oh, it's been past 24 hours. Goodbye, data. I don't need you anymore. That's obviously not as easy to do in some of these other databases, because that's not what they're for, which is great. I don't want to lose my customer data. That'd be bad. That's why it goes into SQL DB. But sometimes I don't need to care about my Plant Buddy IoT system and how it was doing 20 days ago. So, some key drivers for time series applications. Access. Time series data from assets and applications. So what we have here is our Telegraph Tiger, which I'll go more into, but basically it's a open source ingestion agent. When you actually get that data into Influx, you need to start analyzing it. So that's going to be things like performance, availability, and security. And finally, actually act on it. So this is a great little photo of where some of this data might be coming from. Some of these are actually, we actually are used in these products, like we are in the Tesla Powerwall. I'll go into that. And the other one that I don't mention as often is the virtual. So that's going to be things like server monitoring, a little bit more not physical. You can't hold it, obviously. I mean, I guess you can kind of hold a server, but that's not the point. But the big thing with these is just to keep in mind, obviously there's lots of different server monitoring options out there, as anybody who's ever been to the internet knows. The big thing for us is we're normally used for very specific use cases. Sometimes those can be very rigid in what they monitor and what they process. But we are better for our customers who really need customized use cases. So, one platform, one API. So as I've already kind of mentioned a few times here, we have our cloud, which is where I would say a lot of people end up going to. It's free to start out. It's pay as you go from there. Our enterprise, which is mainly just for clients who require on-prem solutions. And finally, OSS, which is our open source, which you can just download off GitHub, run locally, or you could run it, if you want to be difficult, you could run it in a cloud that we already offer for our own cloud. But hey, why not make things more complicated? So as I mentioned before, here is one of our customers using us in the IoT space. So when I'm showing off these use cases, it's mainly just to make sure that everybody, really drive home what we're used for, where we are, purpose-built. So with this, Tesla's using us to monitor the health of their solar and power bank. Obviously, these are devices that send in a lot of data. They can use this data, and in general, they can actually use their historically aggregated data to tell when things are not quite right. Your solar panel, if you've ever bought one before, normally tells you, I'm expected to give you this amount in this time of the year. If it's not doing that, that's normally a pretty good indication that something is broken. So they can normally use that historical data to not only sell you solar panels, but also tell you when things have gone wrong. They need to store that data. They store it in Influx. Disney Plus is one of those server monitoring that I was talking about. They're obviously streaming a ton of stuff. You want to watch your movies, you want to watch The Mandalorian, and you want to watch it fast and not have things, crash out on you. They are monitoring all of their performance on some of their CDNs with Influx Db. And they specifically used us because they wanted very custom metrics for their servers. This is one of our open source use cases, which just to clarify, these are kind of hard to get because, if you're an open source user, you're not really per se talking to us, you just download it off GitHub. Luckily though, Mike has been talking to our community a lot because he had a few issues getting going, so we actually are super familiar with his use case. But basically what he's doing is all of the birds of prey, or a good majority in the UK, have little tags on them. They're basically IoT edge devices. And what he's doing is he is monitoring those birds, and specifically he's getting more data from the tags than they used to get. And they're specifically trying to look for the birds who have their tags, I guess you could say, go dark. Unfortunately, a lot of the birds have been killed during COVID, and they kind of want that to stop. So they're actually using the tags and using our platform and our mapping graph to keep track of all these birds of prey. So hopefully their population gets up and we stop hurting them. So now I'm going to go ahead into the overview. So we are three things. We have our API and toolset for real-time apps, the high-performance engine, and our community and ecosystem. So when it comes to toolset, we have a RESTful API, which is available across the platform. We support multiple querying languages, Flux, Influx, QL, and SQL. We have our open source integrations, which include Telegraph, our client libraries, and our plugins, and then our cloud delivery on the 3 major cloud providers. The time series engine, the big thing to know with this is it's specifically geared up for high cardinality, so that means we're getting, and also high throughput, so we're getting a lot of data coming in, and it processes it super fast. That's the important part of the database, and it doesn't drop any data, that being the second. Finally, the community and ecosystem. We actually have quite a large community on, and I'll go into this later, on like Slack and stuff like that, but these are some of the tools that we are built up with, and I'll go over these a little bit more in depth when I do the demo, and obviously the cloud marketplace. Visual Studio Code, by the way, is on here because we actually offer a plugin that you can use to write up Flux queries in Visual Studio. It was asked for by the community, so they didn't have to come on to the Influx Db platform or the open source to do their work. They could just do it straight inside VS Code. So how it works. This is a really great, graph architecture, whatever you want to call it, to actually show what I've been talking about. But basically, the platform is everything underneath the blue line. That's everything that the platform comes built in with it. Obviously, you could piecemeal some of these out. That's why some of these are actually kind of slightly separated. But the whole point here is that we're not just a database. There's actually quite a few just time series databases, and they do the job. But we are a little bit more than that. We are, yes, the database, but we're also good for things like visualization. We have our own alerting system, as well as things like downsampling, which I mentioned earlier, and I'll go more into. And then, of course, the client libraries, the open source ingestion agent, etc. Yes. I don't know where I'll share them, but I can. I'm also just going to leave this slide up really quick. So when it comes to getting your data into Influx, these are the main options that you're going to have. The big 2 that I'm going to be mentioning today are the client libraries and the agent-based push, aka Telegraph. This kind of goes over like why you would use one or the other, or the use cases for using them rather. Telegraph, to specifically, really drive home what this is. So Telegraph is fully open source. It has about 300 input plugins, and a lot of those input plugins are actually supported by either the company or the product that's doing it. So for example, AWS has a few plugins with Telegraph. A lot of their own engineers are the ones who work on it. It's also used by plenty of our competitors, but it's open source. That's how it works. It's pretty much completely, like I said, driven by the community. We are the caretakers. We make sure nothing malicious or crazy is going on, but luckily we don't have to write everything ourselves, thank goodness. It's also, simple to configure and extremely flexible. So this I haven't really talked too much about, but Flux is our internal querying and analyzing language. It's basically the Flux to Influx that SQL is to SQL databases. But what it allows you to do is specifically to query on time series data, and it was specifically built and written for that data type. So it's a lot faster at handling it. As you can see, it reads, in my opinion, a lot like Python kind of, or JavaScript, some people have told me. But regardless, it's pretty readable. It's pretty straightforward. Even in like this one right here, what it's saying, it's basically, and for those who can't read in the back, it's saying a time range, go through this time range of data. A filter, like I want to see only the city IoT, a measurement of bicycle. And then finally an aggregate window, which is a really powerful tool which will basically aggregate down that data of that data. So like I was talking about before with aggregation and downsampling, that's how you would do it. These are just some of the examples of what you can do with Flux. Obviously, you can query, pretty straightforward. It also has some things that some of you guys might recognize from SQL, being joins and pivots. It also allows you to analyze with things like anomaly detection, downsampling, and correlation. And then finally, action. Now, we do have a GUI for our alerts and notifications, but technically you could also write them in Flux. Task, which are, again, basically just cron jobs. This is a GUI of what a task might look like. But for some people, what they'll do is they will, once their data comes in, they'll run a task that says, drop these specific columns, clean this up, and aggregate it down to the minute or the hour. And then they'll put that new data into a bucket, and that's the bucket they'll actually run all their other queries on. Or they might start separating things out. But basically, tasks are cron jobs that you can run as often as you need to or as often as you like that manipulate your data. This is, again, the GUI version of the checks and alerts. It's just a little bit easier to see, and I'll demo this as well. But basically, it's pretty straightforward. A check, you're just seeing if data goes above, below, or around a certain threshold that you dislike. You pick an endpoint where you would like that notification to be sent. For the GUI, we have PagerDuty, REST, and Slack. And finally, a rule, which basically just says how often you want to be notified and at what point. So with this one, it's saying when status is equal to critical, please send me a Slack message and let me know. So I'm going to go ahead to the demo. Oh no. And of course, it logged me right on out. Here we go. All right, so one of the nice things about being in here is I can actually show things and it's a little bit more simple to understand. So here we have loading in data. So we have our, I'm gonna actually start over here. We have our buckets. This is pretty straightforward. This is where you actually put your data. You can name them as you like. You can also start to tag them. As you can see, I have a bunch of relatively random ones, I suppose you could call it. And then when it actually comes to getting your data in, we have things like file uploads. So that's really great if you already have historical data. We do actually have ports if you want to bring it over from like a SQL DB or something, but in general, sometimes you just want to, do a CSV upload. The client libraries are a really powerful tool. Oh, this one's actually the brand new. Here I'm going to go into, oh no, I guess they all got updated. All right, very well. So basically what this does is it walks you through how to get this all set up. But the end result is that all you have to do pretty much is normally just install a library. That's how you would do it in Python. You go ahead and export your token. You initialize your client with these lines of code. It's pretty straightforward. It's about 6 lines. And then finally, you can just immediately start writing your data up. So this one's already preset to my bike bucket because it's been selected up here at the top. But basically with this, I'm going ahead and writing up to the bucket with a point, and I'm giving it a tag and a field and a measurement. And that's pretty much all the code you need to get this going. I would say it only takes about 5 seconds to get this all set up. It's actually pretty quick. I've done it in less than 10, but every single one of these languages has that option, so it's pretty straightforward. You just download in the library, and in 6 lines of code, you can just start going. Native subscriptions, which includes MQTT, and then all of our plugins, which I was mentioning before. And I will be using one of the Telegraph plugins for a demo, though one of the less exciting ones. As you can see, most of them, I would say, are of the professional variety, but occasionally we get some fun ones like Counter-Strike Global. Sometimes people really like to track their gaming in here. So I'm going to go ahead and, let's see, I'm going to go ahead and add data to this one. So I'm going to use a Telegraph agent, and specifically I'm going to use the system one. So what this does is it's just going to monitor my computer. I'm not going to configure it in any way. I just don't mind. It can just be straightforward. But normally you would get a few different input options where you could say something like how often you would want the Telegraph agent to send data, how big the file should be. It's got a lot of options depending on the plugin that you use. For this one, it's so straightforward it's not necessary. Then I'm going to go ahead and run this in my terminal. And go ahead and give the startup. And this will immediately give me some data for this demo. And it will probably just say that my backbook is running pretty heavy. I don't know, I'm not running Zoom, so it should be relatively happy. I've done this listen for data a few times, and it never seems to work for me. It works for everybody else but me. But normally I do still end up getting data in here. So let's go ahead into this. So yeah, you can see I'm in my system test. I can check some CPUs on here on my MacBook. Let's see, this might need to be a little smaller because the data is only just coming in. Oh, there's my little data point. Here, I might just need to pick something else. Being difficult. We'll come back. That's all right. Sometimes it just takes a little bit of time for this to all load in, obviously. One other thing to note is we offer API tokens. These allow you to basically, this is the token that you would use if you're using the client libraries that I mentioned earlier. They can also be used in like an HTTP request as well. One thing to note, we allow an all access token, which can get into all of your buckets and data and destroy everything. Or we give you the option for a custom where you can pick things for when you don't trust people or even yourself. So that's just one thing to note. Let me see if this now is working. There we go, much better. Yay, data. So basically, this is one of our, obviously, visualizations. This is a pretty straightforward one. It's just called Data Explorer. It's great if you just want to really quickly go in and see stuff. We have a few different graph types. Most of this data is going to be terrible, I would say, for most of these, outside of, you know, the line graph. I mean, I guess the scatter looks okay. It's not very exciting. But one really cool thing that I want to show off is when you go through this, you're GUIing, you know, you're filtering down on this. When you switch over to script editor, it actually gives you the Flux code. So this is how I write Flux code and pretend I can write it. It's really great and powerful. And it also already gives you all of these Flux functions on the side as well for people who are more adventurous than me and actually want to, you know, find some of this information. I'm partially joking. I do know how to use this for the most part. And another thing you can do is you can view your raw data tables. So as you can see from here, this is a pretty good example of how this data looks in here. It's got an RFC 339 timestamp, which reads a little bit funny, but for the most part makes sense. I'm getting values for my CPUs, my loads, and my overall system. And yeah, this is kind of cool to see as the raw data. So let's go into a little bit more exciting stuff, like notebooks. So we have two options when it comes to visualization. We have dashboards, which you can imagine is like a static, I want to answer the same question every day option, like server monitoring. Or you can look at notebooks as the more fun, I have a different question every afternoon, I'm going to keep going back to the data. This is a lot more fluid, it's a lot more scrollable, it's also more friendly if you're working with multiple people, like coworkers. And one really nice thing I actually really like about this is it comes with this sample data, which I think is really cool because it allows you to kind of play around with the system without having to upload your own data. Maybe you just don't have any, or you're just a little bit curious. I'm actually going to do this one because it shows off the mapping. Just give me one sec here. Okay, cool. I'm going to go ahead and run it. Scroll down. This one is specifically built for our map data. I'm going to go ahead and customize this. And run. Aha, there's been some earthquakes here recently in the past hour. This is even more fun if I do the past 24 hours. Ah, there's the San Andreas fault line. So yeah, this is a really cool little thing that you can use here to kind of check out. Like I said, this one is specifically for our map data because obviously it already has the latitude and longitude in it. But you also have the options of using data like air sensor or Coinbase Bitcoin price. That would be a kind of sad graph. And what's also really cool down here is you can start to add things like, I could add like a table, I could add another graph, I could add a note, something like, Jay, stop touching my notebook, leave it alone. And then I can also obviously do things like a query or a Flux script builder. Query builder is the UI version of Flux, and then the Flux script is just pretty straightforward. But as you can see, this one obviously just kind of, well, don't get caught in the map, it just kind of expands and then you can just scroll down. So it's a lot easier to read your data down like that. You can also set up alerts and tasks right here as well, which is kind of nice because everything is just in one spot, it's in one place. So you could name your notebook something like notify of LA earthquakes. And then you could do another notebook where you do something like notify of San Francisco earthquakes. And you could change that data, you could set the geodata to only be in the relative region of LA. Just a quick example of how these might work out. I'm not going to build out a whole dashboard because that would just take way too much time. Let's see if we can get this Plant Buddy one if I do the data for like the past 30 days, because I've definitely run it recently. There we go. So like I said before, this is great for overall static data. So with this, as you can see, I have a little gauge here which says the plant is drowning, the average soil moisture, soil temperature, and air temperature. This is all from a at-home plant monitoring system. But IoT devices from Amazon send weird, sketchy information which needs to be cleaned up, and I haven't done it, which is why the light says it's a 1,000. I don't know what 1,000 light means, but it means the plant was getting light. This is some of the fun parts of IoT sensor data in general, just an FYI. This happens even at a much larger scale. These are the tasks, which whenever you create a task off of the dashboards, it creates this weird gibberish title. It really makes a lot of sense. It makes it easy for me to understand. But if you write your own test, this one is one that we specifically wrote for the Plant Buddy. And basically what it's doing, I'm kind of waiting for all the colors to come up. But basically what it's doing here is it's sending an endpoint to Twilio. We specifically coded this in Flux, which is why we have Twilio as an option. Secret here being that if you code in Flux, you can send your data to anywhere, not just PagerDuty or Slack. But that does involve, you know, a little extra steps. But basically what we're doing here is we're saying if the plant's moisture is below a certain number, I'm looking for where that number is. Oh, there it is. If it's below 30, please go ahead and send Zoe, specifically me, a text that says, I am thirsty and require water. It's really funny when I'm at the booth and running this, and then like, this only sets to run every like 8 hours or something, and I'll get a text later on in the day like, I'm thirsty, give me water, and I'm always kind of like, who is texting me? Where is this coming from? And then eventually I realize it's the plant from earlier, because we never water the plant at the booth, let it be known. That poor thing is about to die always. So this is one example of a really cool little task. Like I said before, the other big one is going to be downsampling, which actually, let me see if I can just open up my Visual Studio Code so I can show you guys. It should automatically open to hopefully the project I was already in. With any luck, this is our very fun little Plant Buddy one. Let's see, where is it? Looking for something in particular. Don't know if my task is in here. Maybe it's in this. Oh, man. Well, regardless, I am not going to go hunt through all this, but basically in here what we actually do is when we do our edge to cloud data, we actually aggregate our data down in here to be by the minute instead of by the second. Because originally the plant sensors obviously send data in by the second, but what we do is we aggregate and downsample down to be by the minute. And honestly, this is a house plant sitting in my house. It could be by like the day, and it would be perfectly finite amount of data, but it definitely didn't need to be by the second. So we did it just for our own sake, and also because I never empty out my data, and I don't pay for anything because I'm an employee, and I'm secretly, you know, storing just a ton of data on Influx for free. And in that way, we also have this is the GUI of our alert system. So obviously, the task was being used as an alert. It was just, you know, a whole Flux file of basically an alert combined with the task. It's not uncommon. But one thing to note is we have our deadman and our threshold check. The deadman is literally to make sure that everything is operating and not dead. So if your data source starts to not get data, it will actually alert you and be like, hey, I haven't heard anything for like 10 minutes. You know what's up? Obviously, this is not great with edge devices, but with normal devices that you expect to constantly be hooked up, super useful to know that something is wrong. A threshold check is probably the more common one. And with this one, let's go ahead and grab my system data. I don't know what's normal for CPUs. Doesn't look like it's doing anything actually, so we're going to pick load instead. There we go. We've at least got some movement. So with this, I could go ahead and set something like the OK level is, and I can actually move this if I don't know, I guess I can't. So I could just set this down here to be like 3, and I guess that's normal. I could do info when it's like 5, and then I could do warning when it's like 8 or 9 or something like that. There we go. As you can see, my CPUs are nowhere close to these wonderful lines because it's all the way down there. And currently I've got the critical. Let's set it to like if it's 0 or something, or let's see, 1. I can set this critical for if it's below. There we go. So as you can see, this is pretty like easy to set up, and you do not have to do all 4 of these, by the way. I just like looking at all the pretty colors. You could just do 1 or 2, but basically the gist here is you could pick out your data and you could be like, hey, if it gets above certain points, please let me know, whether that just be an info, whether that be a warning or a critical. And just a note on this, you do not have to notify on this. You could just have checks running, and basically what they do is they produce, let's see if we can get it to come up. No, that's not what I wanted. They produce a history. There it is. This one won't have any because I haven't run it recently. But basically, they will produce a history that you could read through. And what some people actually do is they have checks on their data, and then occasionally a person will come in once a day, once a week, and they'll just look through the check history. It's kind of like a logger for them, but they're not actually doing anything real time with that data. I know it seems kind of weird because we're all about the real time monitoring, but people use us for whatever they want to use us for in the end. So that is an option. Like I said before, the notification endpoints are pretty straightforward. You set up one that you like, you give it, the incoming webhook URL that basically just says send the data onward to this. And then the actual notification rules, which again, you can set to be something like when it changes from or when it's equal to, can you please go ahead and send me a message? And send me a message every, obviously, 1 minute so I can get angry at you. Or maybe every, 2 days, so that way then nobody knows anything's broken. It's all a secret. Variables, pretty straightforward. These are just all the tags that you see on some of your data. This is great if you're dealing with actually a lot of different types of data. I don't really use this because I just create gibberish data. So I have gibberish tags. Templates are actually really cool. They are basically kind of like the server monitoring in that you can already build out with them. So like they're already pre-built out for you. So for example, let's see, we have a Docker Hub one. That seems kind of useful. Cool. So it already comes pre-built out with a Docker Hub status, and a few of the values that you might want to see in your dashboard are here. Basically what you can do is you install this, and then it automatically starts out with the Telegraph configuration, Docker Hub.config. It gives you the dashboard with all the pre-built out values. It also gives you a label, Docker Hub, and a bucket, Docker_Hub. But basically, this is to set everything up for you. It makes it a lot faster to get going. These are all open source, by the way, so some of these are built by our employees, some of these are built by people who, just really want to build their own and share it. But in general, this is a really great way to just get started and get going. Some of them are even more fun and not serious, like the Fortnite player performance. Definitely not serious. But most of these are going to be, boring job stuff. Unfortunate. But moving on from that, labels very similar to variables. Secrets, doesn't matter, they're a secret. So basically that is the overall demo for the cloud platform. So I'm going to go back into this. But yeah, now we have a much better idea on how this all works, how some of the options work, the capabilities that you have. And just to clarify, because I didn't think I mentioned it, that cloud UI that I was just showing, it was exactly the same as the open source UI as well. So like if you go ahead onto GitHub, you download open source and you run it locally on a local host, that is pretty much exactly what it's going to look like. I just don't want to run things locally right now. My laptop is a little old and struggles. So Influx Db and AWS. So here are a few of our AWS input plugins. Give me one sec. So with this, we offer specifically AWS CloudWatch alarms and statistics. We also have one for Amazon ECS input plugins, as well as AWS, I don't think I've ever pronounced this, Kinesis. It's a consumer input plugin that reads from the Kinesis data stream. Sorry, I've said most of the other AWS ones before, but not that one. So we also have a few AWS Output Plugins. That includes the CloudWatch Output Plugin, which will send logs and metrics to AWS CloudWatch. That blue one is specifically the TimeStream Output Plugin, which writes metrics to the Amazon TimeStream service. And finally, the Amazon Kinesis Output Plugin, that is the experimental plugin, still in its early stages of development, but basically it'll do a batch up of all the points into one put request to Kinesis. Kinesis. Thank you. Sorry, guys, Kinesis. And then finally, Telegraph AWS Processor Plugins. The only one that we have currently is the AWS EC2 Metadata Process Plugin, which basically appends metadata gathered from AWS IMDS to metrics associated with EC2 instances. Another thing that we're currently working on together with AWS is Greengrass. So for those who are not aware, AWS Greengrass, otherwise known as AWS IoT Greengrass Core Software, it runs on Windows and Linux-based distributions such as an Ubuntu or Raspberry Pi OS. And basically what it does is it gathers that data from those IoT use cases. And specifically in here, this is a relative model of how this would look. You deploy Influx Db as an open source component. You connect to telemetry components. You write the data to Influx Db. And finally, you can display that data in Grafana. Obviously, we have our own visualization, which I showed you guys, but many people like to use this with Grafana, and we do have an output plugin for it in particular. And finally, with this one in particular, they're actually replicating the data to Influx Db Cloud. We're actually going to be having a GitHub, we're currently working on it basically, but a GitHub code example for this. We're working with Greengrass on a plugin and integration. So right now that isn't fully complete. So this is just a very small example of how they used it about a year ago. And this is going to be updated. It just wasn't updated in time for this conference. So at the edge. So this is something that we are really, really excited to be talking about because we've been in development for it for like forever, but definitely for at least 6 months at this point. But basically, every industry has an edge. Normally when we think about edge devices, we think about a tag on a hawk or something in the middle of nowhere, maybe out on a farm or something. But the reality is almost every industry has an edge device. These are just a few examples that you can see. Obviously, these are things that would come in and out of Wi-Fi, especially things like customer mobile apps, which are definitely known to do that. And these are all examples of where you might need to use edge to cloud replication. So one of the new powerful features that Influx Db is offering is that basically when you're running an Influx Db open source instance, you are going to have a bucket on that instance. And in that bucket, we are going to have a disk-backed queue, which will basically store that data. So even when you have lost Wi-Fi, you've lost, interconnectivity, it will still have that data stored there. And with that data, you could obviously run Flux queries locally, like I do for my Plant Buddy. But once you are reconnected, it will then batch send up to the cloud while keeping all of your data stored safely on your local device. What this basically does is it solves the obvious problem of you're trying to store stuff locally, but it's not really configured properly, and now you've lost your data, or possibly it double writes. It reconnects a few times, and it just can't, keep up or keep track, and it just ends up, double writing a bunch of stuff, which is not helpful. But this was specifically built out for us to specifically go from an open source instance into a cloud instance with edge data replication in mind. So what we basically have here are 2 APIs and 2 CLI commands that basically define the remote connection and then define where you want that data to be replicated. So basically you say, these are my remote buckets. These are the buckets that I need that disk-back storage. And this is where I want that data replicated when everything interconnects. I actually use this a lot with our Plant Buddy demo at the booth because sometimes my laptop goes to sleep or we lose Wi-Fi because it's at a conference center, and unlike here, there's not routers all over the floor half the time, so internet's sketchy at best. And this is actually really helpful because it's actually really funny. I'll go to lunch and our graph will have, a big gap on it because the plant's data is no longer being sent up because I went out to lunch and the computer turned off. I reconnect it, and all the data just gets pushed right up. Now, I'm dealing with, obviously, a very small amount of data. We do have limits to how much you can just push, obviously. You can't just, send terabytes of data up a file. But in the end, it will all end up on the cloud, as long as it's, connected long enough and the data is not ridiculously massive. You can find all that information somewhere on our website, I am sure. I just don't have those exact details. But basically, this is obviously, like I already kind of talked about, this is just adding value to the Influx Db ecosystem. We work a lot with IoT devices. And in general, edge devices, like I said, it can even be something like a plant demo at the booth. You never know when you're going to lose interconnectivity, to be honest. Outside of maybe at a server farm or something that is really interconnected, a lot of things could lose Wi-Fi, and then you could lose data. So for a lot of our users, they're actually really excited about this because they're going to use it for things that we wouldn't necessarily really consider edge devices, but more of just like a backup. I'm kind of nervous that I might lose my data one day, and this is a great backup solution. These are just some of the nice things about this. Obviously durable with that native queue. Automatic, it's not super complicated code to get this going. It's literally like 2 CLI lines, it's super simple, and it's very flexible. This is literally the IoT Edge example of my Plant Buddy. This is the plant right there. And as you can see, I'm running, this is supposed to be an example of the fact that I am running a Flux query here to downsample it into the downsample bucket. So what's funny here is I'm actually getting my data into my first bucket called Plant Buddy, which I am not actually backing up per se, because then I'm immediately running a Flux query to downsample that data, and that's the bucket that's actually being replicated up into cloud. So that's the other powerful tool there, is you can actually just go ahead and not analyze. You can go ahead and manipulate or downsample your data right there on the edge device, and then you can only upload the one that you actually want, you know, the one that you've already made smaller or made cleaner. So these are fun. So this is for try it yourself. So this is a hash code to our QR code, sorry. This is a QR code to our cloud website. The other one is to our open source and our community. That's where you can find all of the code, including for some of our examples, like right here you can see my Plant Buddy project hanging out. But this is also where you'll find stuff like Telegraph, our Influx Db platform, etc. One quick shout out I want to give is to Influx Db University. So with Influx Db University, they pretty much helped me sponsor out this course, but basically it's a great spot to learn more about Telegraph or Flux or Influx Db Deep Dive. Just in general, it's a great resource to go over some of the more advanced topics and really become familiar with the platform. And it's completely free. You don't have to pay anything for it. These are just a few further resources. I normally just put these all on one slide just so that way then they're a little bit easier to access. But basically, the getting started, the forms in the Slack. So one thing to note, forms are great if you have a question and you think somebody else has already asked it. It's very easy to search. Slack is kind of a disaster zone. But Slack is great if you just want to interact with the community or you have a new question. That is a perfect spot to go. Or you just want to talk to us. That's fine too. We're there. And we also have our GitHub, which again, as I just mentioned, all the code lives there. Also, if you want to put up issues, even if you want to first talk to us about it in Slack, you could just go straight to GitHub. We accept them there too. Our book, which kind of talks a little bit about the original reasoning behind Influx. And it's not as, docky as our docs. It's a little bit more fun and readable. Our blogs, which talk about not only our use cases for like our big customers, but also some of the more fun ones, like Plant Buddy or one of our coworkers has been monitoring their grill for smoking meat. I really want to try it at this point because I'm tired of reading about it. And then obviously Influx Db University. So yeah, if there's any questions, you're welcome to ask. You are correct, we have C#. I'm afraid we do not have C++. That being said, though, there might already be a request for it, or you could request. We are open source, so I swear some of these have already come from some of our users, for sure. So so can you clarify, are you talking about like you wanted to schedule something on your own machine to run, or?
So thinking like you have some data in a service that needs to be accessed through their open APIs, but they don't provide you to like build an agent on their service or anything like that, so you kind of just need to code to open up their API and pull the data down.
You could probably use the client libraries. You could write something that would specifically pull that data into maybe like a Python file or a cron job file and then write it up to Influx. That would probably be the fastest way to go, especially now some people will actually create Telegraph plugins just to get around that, but if it's especially closed, it's not safe or whatever, it's for security reasons, I would say the client libraries are probably going to be your fastest bet.
And that's all hosted on the service itself.
Yes, that's right. You can't just So one thing to note is you can't piecemeal us. This all comes, don't worry, we're a super, super light GitHub package, but this all does come pre-built in. I'm going to actually go back to just the main page. Are there any other further questions? Yes, I can. There we go. Here, I'm going to full screen this as well. And you had a question? Mm. So I'm not personally super familiar with Elastic, but from what I understand, some people do put some of their time series data in Elastic and it works out okay. I think it just depends on the data that you're putting in. Because obviously Elastic does deal with a heavy amount of data since they are like a search, they're mainly used a lot in like searching and logs. And that is one thing to know is we're more events-based than we are log-based. We're not quite as good for that yet. We're rolling out some new features which will make us a little bit better on that front. So that is one thing to keep in mind. I'm sorry if that doesn't fully answer the question. I think that, yeah, that happens a lot in general is that people will use other databases to, solve their time series data problems. And I will say sometimes it works just fine. And that is one thing is if you came to me and you were like, I'm not dealing with any pain points, I would be like, that's great, then stay where you are. I mean, clearly it's freaking working. Because I've definitely had people come up to me and they're like, well, why should I switch? And I'm like, well, are you in pain? And they're like, well, no. And you're like, well, then don't. Why give yourself extra work? Who needs that? But if it is giving you pain points, you can definitely look into Influx. You can always ask us or on the community and just be like, hey, I have this issue. Will this solve this issue? And if we're like, we'll be honest with you, we'll be like, actually, no, this is not going to help you at all. Or we'll be like, actually, this will solve some things. It's one of those things where there's nothing perfect out there in the world in databases in general. There's always going to be cons and pros, and some jobs are just better dealt with in other solutions than us. And we like to be honest and upfront about that because I can tell you right now, it is a lot to move data off of databases. It is extremely painful and it is not fun, and it's probably the biggest reason why sometimes users are really angry at us is because they're moving their data from somewhere else and we have to help them, and it sucks. So it's best to get it right the first time, for sure. Any other questions? If there is no other questions, everybody who asked and everybody else in this room, you're welcome. Look at these wonderful socks. You are welcome to come get some awesome socks. Look, it has a database on it. They're very unobtrusive, and they're one size fit all feet. We are non-discriminatory on feet. But yeah, everyone have a fantastic time this week/weekend, I guess. We're going to bleed in for sure. Oh, what is it?
Product-led growth.
All right.
I think it means focusing on the quality and performance of your product. Like if you build it, they will come strategy.
All right. That makes total sense because our main, I don't even know what you call it, slogan is time to awesome, which basically means we want to make developers' life as easy as possible so the time to awesome is faster. And that is a big thing is because we're open source in general, we do listen to the devs, we listen to people when they come to us with complaints, and that's how we build out. I mean, that's where edge data replication came from, is people doing janky solutions and complaining and us going, we should fix this, guys. Like, we should just make this a lot easier. That's where every tool came from. It all came from, hey, I'm a C++ developer. Where is my plugin? And we're like, we can help you with that. Or it was, I really need to do alerting, and I'm doing it on some other weird thing. And we're like, let's just put this all on the platform so you stop hacking around, basically. But awesome. And yeah, like I said, don't be afraid. Come on up and grab some socks.
skeptical about, oh, I can start. I was originally super skeptical about running like data workloads on Kubernetes. Anyway, I'm going to do kind of a survey here. No, I may kind of hop and jump some slides. I'm just going to talk if we're not recording because I think everybody can hear me.
Recording.
We are?
Yeah.
All right. Well, if we are recording.
Do you want the earpiece?
Oh, I don't know. Maybe I do. I do. I'm not live coding. No, sir. Oh, this is good. We should have done this before it was hot. How's that? Is that too much beard noise? Okay, great. So I'm going to tell you a little bit about what I've observed. I work for a company called DataStax. Anybody ever heard of DataStax? We've got one. We've got two. Rags. I'm so glad you raised it just now. I'm so glad you raised your hand on that one, Rags, because that would be very confusing if you hadn't heard of it. So DataStax is the company that primarily cares for the Apache Cassandra project. And Apache Cassandra, up until maybe 5 years ago, there's this idea in computing that you have one of two types of problems. You're either trying to make impossible things possible, or you're trying to make hard things easier. And they're two very different types of work. And for a long time, Cassandra was about making impossible things possible. I need data, first order data, East Coast, West Coast, and Europe. And I need it to be mostly in sync because I can't make people in India pay a tax to access my system because it's slower. It's a hard problem. It's gotten easier, more people do it. There are a lot more NoSQL databases in the world. They're all a little bit different. But I've been working with Cassandra for a little while, and this is kind of me gelling my ideas from a data perspective about how I've seen people build applications that geoscale. I don't know, I might be coining that term, but we talk a lot about vertical scaling or horizontal scaling. But that's all still like a piece of butter in the middle of the toast, right? Like a big stack of butter in the middle of the toast. And the toast is very big, and it's a long way to that vertical or horizontal scale. And geoscaling is a different problem. I think we're all going to live here. I think the line between a cache and a database is blurring as applications aren't just about serving people in one factory or serving people well in like one region. So that's me. That's a much better picture of me. When you think of me later, think of that picture. DataStax, we want you to use Cassandra, is the short version of that. I've talked in this framework a few times about the three characteristics I want to see when I see a big distributed system. Big is such a weird word. It's so subjective, right? Like, what does that mean, big? This is, you know, the account correlation behind Capital One's, all of their assets. This is, I haven't personally gotten to work on this, but this is Netflix's measurement of what you're watching. This is data that has this ubiquity to the, let me go too grand here, this ubiquity to the human experience across the globe, right? And it doesn't make sense for it to sit in Arlington, Virginia, or Alexandria, or wherever you first design. It avoids these complicated bottlenecks that create that penalty. I'll try to break that down a little bit, and then you guys can call me out if I'm just being a crazy person. We need repeatability, and I bet we're going to talk about Kubernetes on that one. But the more surprise we experience, the harder it is for us to maintain and resolve issues. So the more common things are, the more repeatable they are, the better. And we need observability. I'm not going to talk about observability. Not in this presentation. There's a whole track about observability. It's a big deal. Get good at it. Cassandra was super successful with the people that would read the system logs that came out of Cassandra and hard for everybody else. And that was an observability problem. We've tried to do a lot of work on that, but make sure you can see what's going on before you get started. Autonomy. So ideally, in this big, magical, globally distributed system, we'd have a bunch of workers doing things. But the more those workers have to interact, the more bottlenecks are in our system. And that can be okay in a single data center where our mean latency between two machines is what? Less than a millisecond? It's nothing. But if we have to build consensus between US East and US West, that's 100 milliseconds, right? That's time that bottlenecks and locks and adds complications and forces you to run into problems when you start to hit scale, because anything that slows you down stacks you up. Do you guys, anybody, I'm going weird here. I actually did just throw up a slide with the Oxford English Dictionary. Anybody ever look at the Oxford English Dictionary? Anybody know the history of the Oxford English Dictionary? Do you? That's close to the copy that my dad had when I was a kid. That's the compact Oxford English Dictionary. It came with its own magnifying glass. Somebody decided, we talk about like big data and these distributed computing problems, and we think that they started in like 1973. A group decided to make a dictionary of the first occurrence of every word in the English language. And it's 40,000 words, 400,000 words. It's big. This is like post-Middle English. And so some editors sat down and tried to go through everything anybody ever wrote in English and find the first occurrence of words. And they thought it would take 10 years. It didn't. It took a lot longer than that. But the thing that actually allowed them to fix it was one of the first big data distributed workloads that I remember hearing about. Because what they did was they made a list of words that they cared about, and they mailed it to every reader. They'd put it up in bookshops, and all of those readers would come in and say, ooh, I found an interesting version of the word abacus in this book. And they'd all mail it back in, and they'd collate it, and then the editors, having worked with the whole field working with high autonomy, could then do that last little bit to try to find the best reference. And the book, this would never have been completed if not for that. And this is, to me, a major, major thing that humans were able to pull off. To bring that back to this whole cloud data topic, our developers spend a lot of time talking about autonomy in their code chain. They do a lot of work on it. They're people that are big proponents of the actor pattern. They're people that like to talk about how all the OOP people just don't see the value of functional programming. I'll do that later if you want me to. We have this idea of share nothing architectures or microservices, and these are all about isolating things out. So all these people can talk to this beautiful Lambda. There's no connection between those Lambdas, right? That's perfect autonomy, right? Until it hits the database. And databases are beautiful. An incredible amount of work went into relational databases and what it means to relate data, how these things correlate and how we can keep them sort of perfectly consistent. But it also destroys our isolation. Anybody here familiar with the CAP theorem? Rags is. If you ask database people, they'll tell you they know what the CAP theorem is, and they'll either tell you they like it, or they hate it, or why it's stupid, or why it's amazing. But the thing about the CAP theorem, and there's a reason I bring this to like a discussion from an AWS perspective, right? And to this big like distributed cloud discussion. The CAP theorem's worth reading. It's a couple of pages. It's nothing, and it's all about network clocks. But the CAP theorem wasn't about databases. It was about distributed systems. It said, look, if you're going to build a big distributed system, there are three things you might like. You might want perfect consistency. If I get a birthday invite from Tokyo and somebody from Berlin asks me if I've been invited, there should be no delay between the time I got the invite and my answer that I was invited. That's consistency. Remember I mentioned that 100 millisecond delay? That's entropy against consistency. You don't see it in a single region, but as soon as you start to spread that butter out, you have to deal with it. The other thing that would be ideal is perfect availability, right? Like, we want the system to answer our question every time. Because if the database doesn't answer, or, see, I just did it again. If our distributed system doesn't answer, then it's broken, it's down, right? And the last thing that Cap said we have to contend with is this idea of partition tolerance. It turns out that computers break, and the more computers you use in a system, the more you're likely to have to contend with that. So if you have one copy of your data somewhere in a big distributed system, when that partition's off or breaks, you have no means of dealing with that. And CAP was one of these, pick two theorems, right? You can be consistent and available. You can be consistent and partition tolerant. You can be available and partition tolerant. It's not really true. It's actually one of the criticisms of CAP. It's really about consistent versus available. I say that database people talk about this a whole lot because a lot of us from a data layer say, my data layer is consistent. The truth exists here. Everything is linearizable. I'm ACID compliant right here down. And so this is perfect, and let no one impugn the quality of my data. That's not truth. Truth is up here. It's coming in from the outside, and those lambdas that we talked about have different execution times. They have retry logic. They have lots of things that change the way they execute. So if you enforce truth here, you ignore what the truth was up here. And this is one of the reasons why I would argue, oh wait, I forgot my FUD slide about geoscale. Let me scare you a little bit more. We talked about that latency between regions, right? So that consistency promise, if we just do it right here where I live, well, what about the 100 milliseconds it took for somebody from over here to send that message? And it got to the database later, and they lose. Consistency says they matter less, right, than the person that was here, because they have to go further over the wire. And truth only exists in our database server, so it doesn't matter who was actually first. So the first thing, before we get into a bunch of really boring slides, is I just want you to take a minute, if you're thinking about building distributed systems, and step back from your fear of perfect consistency at the database layer and start to think about what it would mean to embrace an available partition-tolerant database, a database that's going to get the reads in. I'm going to talk to you, or get the writes in. I'm going to talk to you a little bit about how we would build for that. I've got way too many slides on. I'm probably going to blow through them and get to the other good stuff at the end. But a couple of things, if I've convinced you at all to think about when you're building this way, is first the idea that you should prefer events to transactions. If someone increases something a little bit, don't try to update the whole row. Capture that the thing was increased. We'll show this a little bit. You should prefer denormalization to joins, because every time you do a join, you have to build a consensus and spread across a bunch of nodes. And if you call that from that other side of the world, a lot of times it's got to come, I mean, you might be lucky and have read replicas and be able to do it, but you start to do that on a write, and you're locking a bunch of resources into a dance they have to resolve. Treat the data layer as a journal. Reconcile state at read time. If anybody's ever, oh, this is a dated reference. If anybody's ever kept a checkbook and reconciled it, or built financial software, people in finance already know this. They don't give you money because their database says you have X dollars. They give you money if your database said you had X dollars X amount of time ago, because they understand the latencies in their system. They know that just because the database says it doesn't mean that something couldn't be clearing from 2 days ago. So that leads us to this next point of understanding the potential system latencies and how they impact certainty in your logic. But I think this is a pretty big deal because, again, we just check the box and say my database is consistent, so everything's fine. But again, the truth is out there. The check is in the mail, and we need to reserve it. We need to deal with it whenever it was written, when it entered our system, instead of when we received it in a lot of cases, particularly when we're doing geoscaling. And then the last one, oh, I didn't know I wanted that. Now I do. The last one, so you guys have probably heard in the news a bunch of social media networks have gotten launched for different people for different reasons. I can monitor those social media networks and I can tell you whether or not they're going to crash. And I do it with one simple heuristic. Do they have an auto-incrementing key? If they have an auto-incrementing key, they are going to fail every time, because auto-incrementing keys are the worst version of consistent. Every row I have to write, I have to get consensus across my entire data layer to build an auto-incrementing key. It's a smell, and if you want to scale, that's a good place to start thinking about the point that I'm making, why that's dangerous, and how you could deal with that. So, Cassandra, how am I doing? I feel kind of wordy, but we're doing okay. Anybody asleep yet? Anybody have questions about that? Somebody must have wandered over from the Postgres session and is deeply offended by what I just said. Nobody? Okay. Cassandra deals with this availability first design by saying, look, we've got a ring of nodes. This ring is this idea, like we're in a data center or whatever. We got 15 computers we can use for this problem. Each of them is a node. So we're going to coordinate them into a Cassandra data center. This is going to get horrible too, because data center is such an overloaded term like cluster or whatever. But we've got this ring, and we want to write data into it. So we're going to, and we'll deal with this a little bit, we're going to look at something. I don't want to join the Hilton Honors Network. Maybe I do. We'll see what happens with my slides. When data gets written, this is really all Cassandra is too, you know, with a little bit extra. When data gets written to Cassandra, I wonder if I can just auto-log in. Oh, I can sign in for guest Wi-Fi. This will go down here, and we'll all be aware of it the whole time. When data is written to a Cassandra data center, that data can actually be written to any of these nodes. It doesn't matter. And that node will work as a coordinator, send it to one of the typically 3 replicas that own it, and then return back to the writer, it worked based on how durable a promise they want. It doesn't actually change the way it writes, but you can say, I only care if one replica gets it, confirm it then, which is roughly the equivalent of, I'm going to hand out birthday invitations. Hey, did you hand out all the birthday invitations? Well, I can guarantee 2 of them got out. It's going to happen in the background. That's actually a horrible analogy, but it's going to happen in the background. It just depends on how much I want to audit that process as a writer. That write goes into replicas. That write also immediately goes to other data centers. So that could be US East, US West. That could be on-prem and in the cloud. There's time here in that replication. We don't wait for that time to come back to you. It's 100 milliseconds. Again, understand your system latencies when you're modeling. Don't write here and then immediately read here. You know, give it 100 milliseconds if you can wait for that to happen. But those writes are replicated. The reads come in and can read from 1, or often they'll read from quorum, half plus 1, so they know they're going to catch anything that was written. And that means anytime we read or write, we involve 3 nodes. 3 nodes means nothing ever gets more complicated as we add nodes. I recorded a podcast for AWS Containers in the Cloud. Anybody know about it? It actually seems pretty good. I don't think enough people watch it. We just ran a 1,200 node Cassandra cluster on EKS with near linear scalability. You add a node, you get the resources. You add a node, you get the resources. You add a node, you get the resources. Turns out about 1,200 nodes, the gossip protocol blows up and you don't get any more resources. Bad things happen. But we continued to be able to add nodes, and we weren't getting 10% back. We were getting 90% back with each node we added. And this is why you also get single-digit millisecond latency. Data is shared in real time on that back plane. And any of the nodes can deal with writes or reads. This is actually kind of profound because if you're used to working with consistency-oriented databases, they'll tend to have a write leader, and that write leader will throttle any write activity. Again, we talked a little bit about some things you need to do if you do things this way, but Cassandra, because of this, can take these massive write workloads because it only needs to involve a little bit of the cluster, and it doesn't have to single point it at that leader for each write that comes in. I'm going to lose my, all right. So I alluded to this already. It means availability across the globe, right? We have that replication. We can be hybrid. We can be, don't tell the AWS guys. I can't believe you put Google in your example. We can be multi-cloud. We can be multi-region, which is the most common version of this that you see. And that means that we can keep the data near the input or the consumer. That's why I say databases and caches are going to get a little fuzzy, particularly as we get further out to the edge, right? But that means high availability and low latency from consumers. I know a company, and it happens to be my company, and this is super embarrassing because we're supposed to be good at this, who siloed the control plane for one of the applications they released in the East Coast and then sold that application in India. And it took a hot minute to realize this was miserable for them. Horrible experience. We should have probably known better given our background, but you know, people make mistakes. So I'm going to go through this kind of quickly. Are there SQL people here? Are there people that build databases here? Does anybody actually design third normal form? And the short version of this is when I build a relational database, I describe the data and I model the data. Was that like a half hand? Oh, okay. When I build relational, I'm building this sort of perfect notional form of the data, this like platonic ideal of how the pieces of the data come together. And when I'm doing Cassandra query modeling, I'm doing some of that, but the other thing that I'm doing is I'm actually looking at how people access the data and trying to reduce the amount of replicas that people have to talk to when they talk to the data. I really feel like I've got a bunch of good slides here that I'm happy to make available that talk about what this looks like in a data model, but I really feel like I'm going to hear some snoring if I go heavily into it. I'll stop on this one though. When you're modeling data, Cassandra has this idea of a primary key that speaks to the uniqueness of a row. It has this idea of a partition key that tells us what node that row lives on, right? Because the big thing we need to do is traffic route. If I get a read, who do I ask? If I get a write, where do I put? It has an idea of the ability to control how large a partition is. This is probably worth calling out. Someday I need to write a book describing all the different NoSQL databases as like office politics. You can actually get an idea how all these play together because this is all pretty esoteric if you hadn't gotten into it. But there are key value stores. Anybody know a key value store? No. This is interactive now. What's a key value store? Can you throw one out? Redis, awesome key value store. There are key document stores. Anybody know a key document store? What's that? Mongo, yeah, the king of the key document store. And then, what's that? And then there are key columnar stores. And Cassandra is one of the key columnar stores, I think based on the big table paper that came out of AWS, came out of Amazon. Key columnar says, I want a pointer to a block of data, because I might want to be able to aggregate on that block. Key document says, I want a pointer to a sort of nondescript munge of data that's not just one thing. And key value says, if I get a key, I want the cache key or whatever back. Like, they all have different uses. But in Cassandra, understanding that partition keys help decide that size of the partition block is a big deal. High level, when we're designing for this sort of availability first, we're looking at the data requirements, we're identifying entities and relationships, but keyly, we're identifying access patterns in the data. How will users query it? Because we want autonomy in these queries. We want to talk to as few things as we possibly can, because that's how we get speed back and that's how we scale geographically. This is codified into some modeling principles. Know your data, know your queries, nest your data, and most importantly, duplicate your data. Gosh, if you can, I'm so lucky nobody here is a big database head, because they're going to hate the duplicate your data stuff. It's what we do in caches all the time though, right? Caching is duplicating data. And some days, if you do this on Cassandra, you don't actually have to put in Mongo and then use Redis as a cache. So we bring that together into a logical data model that results in a physical data model. This is way too deep for what we're doing. Here's a logical model of things coming together, the idea of a venue and a digital artifact. This is actually kind of a fun process that one of our guys put together, where we start with the notion of what artifacts by venue is, and then we sort of work in the partition key based on the queries we're getting, and then we want to order how it goes to disk with clustering columns, and then we decide that that order should be the other direction. And then lastly, we use another clustering column to get down to the idea of uniqueness in a row, so we don't accidentally overwrite every venue name and year, because that would be pretty useless. This is that same process again of a conceptual model around IoT. I hope this is actually making some sense, because I'm going through it way too fast, but I do want to stop here, because again, we're in this world where we came up with a conceptual model, but then we had to look and think about how we actually query and interact with the data, which is the big lesson I want to give you. And I think I made that point a couple of minutes ago, but when we're going for autonomy, we need to build the tables in such a way that we don't have to do things like joins to get data back, because again, at scale, we start to jackknife as that happens. We've got great examples of data modeling. Again, last session of the day, so I realize that this is a little bit of a cyanide pill to people staying awake, so I'm blowing through, but DataStax Academy 2 is a site that we have where we do a ton of work on modeling and dealing with this. If you are going to go availability first in your application design, and I think you should think about it if you have to go geoscale, take the time to go through this, understand the difference. There was a process that I watched over and over again that was a little bit heartbreaking, where people would realize the power of Apache Cassandra, realize that they needed it, deploy it using what they learned from Oracle or Postgres or whatever, and then rebuild it 8 months later, because they hurt themselves very badly on it, because they didn't take the time to understand really fundamentally why they were doing it. I'm going to skip through this. I want to talk about the fun stuff. I will pause at the idea of key takeaways. Know your data, know your queries, nest data, duplicate data. A query should be satisfied with a single partition, if at all possible. Primary keys give us data uniqueness. They control how our data is distributed, and they control how data is queryable. There's a dark side here that you mentioned earlier, which is it can be very hard to experiment with Cassandra data, because you're modeling everything off specific queries, and as soon as you need to do analytics or get a different view of the data, it can be really tricky. That's a thing that we can talk about in another conversation. There are things like change data capture in modern Cassandra databases that make it really easy to push into stuff like Elasticsearch or drive your data. I'm a big polydata person, where I want a search index and I want a time series index, just like Influx was talking about before, depending on the query. It's not harder to build this way, but you really do have to have, Bane break your back and you go up to the Himalayas for a week and learn how to be Batman all over again. So, well, it really wasn't a couple of weeks. Is that reference too dated now? Okay. I'm going to jump to the good stuff. So let's talk about repeatability, because here I can give you another anecdote. Does anybody know about Eli Whitney and the cotton gin. Does anybody know about a guy named Brunel? This is weird. In the history of interchangeable parts, every time I touch Kubernetes, I think about Brunel. Maybe because it's a nautical analogy. But in like 1830, there was a need in one of the British shipyards to produce a bunch of blocks, like 30,000 of these blocks. And up until that point, it was bespoke and artisanal. There were people that would sit down and whittle these things out and build them, which was great because when they broke, you could just throw them away, and it took forever to do. And Brunel was a machinist who actually designed some machines to build these blocks. And this is important in the history of interchangeable parts because not only was Brunel's team, there's a dark side to the labor reduction that happens in this quote, but not only was Brunel's team able to complete this, they were able to make it better because the uniformity of the product, the ease and the celerity with which they were able to do it so blew out the old method. But the other thing that happened too is the parts of the blocks that Brunel made, I mean, you're on a ship in the ocean, things break, they were interchangeable. You could rebuild them. You understood. There were no surprises in the way these blocks were put together. And that gave a lot more ability, even to the sailors on the ships, to adapt to problems in a way they hadn't been able before. They didn't have to whittle a new block. I alluded to this when we were talking earlier because I was going to go deeper into this. That's Kubernetes. If you are not paying attention, pay attention. Kubernetes is doing that now. If you're building big distributed systems, we talked about autonomy. We're talking about repeatability now. This is where it happens. This is the add slide instead of the sign slide. We'll do this for you if you want to play around with it. We've got this awesome implementation of Cassandra on Kubernetes called AstraDB. And when you find out how expensive it is to run Cassandra when you want to play with it, because we really tell you to run like 6 beefy servers, because you should for real workloads, go play with Astra until you're ready to actually run it on 6 machines because you have a workload that can't go down. Kubernetes leads me into something that we have been doing pretty recently, and this is, I'll go through this and then we'll pretty much be wrapped up on this. But this is the repeatability part of this presentation. We have doubled down on the idea of running Cassandra on Kubernetes. A lot of people are afraid of stateful workloads on Kubernetes. Don't be. Lots of awesome things are going on about this. But a lot of the headache around putting something like this on Kubernetes is resolved when somebody gets together and writes a really nice Kubernetes operator for you. And that Kubernetes operator knows how to take a CRD that you upload to it and turn that into something useful expressed in pods on that Kubernetes cluster. That's Cassandra. It's the Kubernetes operator and the Cas operator that drives Cassandra. Cassandra is production ready. It's cloud native. It's Apache Cassandra. It runs on Kubernetes, and it's also multi-cluster, which is actually, just for the Kubernetes nerds, it's actually super cool because Kubernetes is not multi-region. By definition, it's not. That's not what it's designed to do, and it shouldn't do that. Other products have been put into that space. Cassandra operator, if you give it the keys, it'll actually build you multi-Kubernetes clusters, Cassandra clusters, to span the globe, US East, US West, Europe, wherever. One Cassandra operator will rule them all. The other thing that happens a lot when people want to go do a Kubernetes deployment is they just get the primary thing running on Kubernetes and they forget that you have to come back to work on Monday and it's got to continue to do things. Cassandra, it doesn't just come with Cassandra. It comes with Prometheus and Grafana for monitoring observability. If you guys have heard of it, it's very important. There's a track. Pay attention to it. It comes with Medusa that manages backups. Because, you know, backup and restore, that's something people like to do occasionally with data. It comes with Reaper that is an anti-entropy mechanism for distributed data in Cassandra. I feel like that's either a long discussion or just trust me. And we'll stay with trust me for right now. It also comes with this awesome project called Stargate. We had this whole deck of slides that I blew through that were all in like this SQL dialect. Stargate actually allows you to talk to Cassandra in GraphQL, REST, gRPC, and this is all in open source. Like, I mean, you know, come set up an account on Astra or look at our DataStax Enterprise, but before you do that, run it in open source, and don't bother to learn CQL unless you are, where did our C++ guy go? I was thinking about him when I was thinking about this. Unless you're the C++ guy, you just got to get that speed. Cassandra relies on the idea of a control plane and data planes. Really, all I'm telling you here is, remember how I told you Cassandra can run, do I need to go back so you can see the command? Okay. It is a Helm chart. Typically, what I'd recommend is distributing the Cassandra operator with a Helm chart. And then when we talk about creating Cassandra clusters out of that Cassandra operator, I'd recommend, it's just a CRD that you're applying. It's just a kubectl apply. I really want to see that in like a getOps or something. But so we create a control plane. That control plane is responsible for creating clusters. It's Helm install Cassandra operator. There's not much to it, assuming you have a Kubernetes cluster like EKS, if you've heard of it. I can vouch for running lots and lots of Cassandra nodes on EKS. In fact, our Astra database as a service also runs on EKS. Once we have that controller in, we can materialize a couple of data planes. If you're playing with this, you don't need to do all this stuff. If you're just going to do one, this is the big complicated example where you're running in multiple regions. You can basically skip this step until you want to go big. You can even skip this step when you first play, but we do actually have to set up some keys and some consensus between the two when you're going big. And then what I really want to show is this. We saw this earlier with your presentation. It's just a YAML description of a Kubernetes resource. It's just a message to the operator that says, hey, man, I want a Cassandra data center, and oh, by the way, can you actually split it across availability zones and tell Cassandra about that so it replicates the data in a smart way? And I want 8 nodes, and I want to use standard storage, or I want to use something else because I don't want to do it through EBS. We've done it through EBS, it's fine. I want to configure the heap size. You don't need to do any of that. I want to pass specific stuff down into the Cassandra config. You don't need to do that because you don't have to think about the Cassandra config all that much anymore. But when we have that in place, we just deploy. When I did that 1,000 node test, I actually structured it as I'm going to do 15 nodes, and then I'm going to grow that to 50 nodes, and then I'm going to grow that to 150 nodes. And the process of growing 15 to 50 nodes, anybody guess what it takes to requisition 35 additional Cassandra nodes from Cassandra? I updated the YAML and applied it, and then Cassandra likes to wait 3 minutes between each node, so then I watched a lot of YouTube videos, and then I came back later, and I had it, and I kept doing that until I had 800 nodes, and then when I had 800 nodes, I realized that I actually needed to pay attention to the subnet size, and I hadn't, and I'd run out of IP addresses because of the way EKS uses IP addresses, and then this is really fun. This is either the worst thing you've ever heard or the best. It was Friday night, it was about 7 o'clock. I didn't want to bother the rest of the team for this example. I had an 800 node Cassandra cluster. I was getting near petabytes of data with the data density that I was dealing with, and I didn't want to ruin anybody else's weekend. So I did a Helm uninstall Cassandra, and I had autoscalers set up in EKS. 5 minutes later, my 800 nodes of M5 4XL, like, this costs more than $1 an hour. My 500 nodes, 5 minutes later, were gone. And the idea of what that would have looked like 10 years ago, when I would have to start calling contractors to come pull stuff out of the data center, like the flexibility of being able to do that is profound. And I knew I could recreate it too. And when I recreated it, there wouldn't be any config drift. I wouldn't have to deal with one node being misconfigured because I had 3 teams working on it. And it would take me 1,000 times 3 minutes to do it because of the way Cassandra liked to bootstrap. If you're curious about deploying a multi-region cluster, I feel like Rags might be talking about that tomorrow. Are you talking about multi-region clusters tomorrow? Multi-cloud, even better. And maybe a little call out too. Even if you're never going to use Cassandra, you should take a look at this project. This is actually a really cool implementation on Kubernetes and understanding what the engineering team did here. And this is all open source. We like to pretend like all you have to do is helm install Cassandra or Cassandra. This is a little bit more complicated. There's 3 commands, really. And it's an apply, but it's so shocking compared to the days that I spent with. Have you guys ever gotten like a multi-terminal where you could open a terminal and then echo the command into 15 different servers? Have you done that with 500 servers? Every day that I went to a client to look to see what was wrong with their 100-node Cassandra cluster, the first thing I had to do was use a script. I didn't write it anymore. That went and compared all the configs on all the servers because that was inevitably going to be the problem. It's declarative with Kubernetes. So if we go back to those 3 big tenets, autonomy, look at availability first. Don't be afraid to let go of consistency because consistency, like the cake, is a lie, right? And repeatability, look at Kubernetes, it's time. And observability, go see some sessions tomorrow. That's it. That's all I got. I don't have any socks, but I'll answer questions. So when you're multi-region, you have to do the work to allow the pods to communicate with each other. What's that? I've seen it done a couple of different ways, and Rags can actually probably talk to that a little bit better than I can. But you do have to have each IP of each pod be addressable to the other Kubernetes cluster.
So it'll make the clusters for me, but I have to tell it how to talk and who to talk to.
Yeah, whether you're paying for a fiber connection through somebody, or don't do this, putting it on the public internet and letting them talk, or setting up some sort of VPN and IP tables, every node needs to be able to talk. One of the nice things about EKS is that it assigns like first class, I don't know what the word for this is, IP addresses through that CNI for every pod, and it makes it a lot easier to do that connectivity. Rags, if you're curious, I bet he'll talk about it tomorrow too. He's done a ton with it. Yeah.
Which essentially, flattens out the network on the multiple cloud. And I'm by no means a networking expert. All that you need to do is just set up the accounts on the different clouds and set up the IP addresses, and then I have Terraform scripts.
The cool side of that is we've seen multi-cloud, but we've also seen cloud-to-cloud migrations with 0 downtime for the application. Just none. Because of the stuff you saw with replication and Cassandra. Anything else? I didn't hear any snoring, which is a good sign. Nothing? Cool. I explained everything. You guys are all high availability experts. This is just some of the stuff I've seen as I've worked with these applications. I hope it's useful to you. And it definitely is through the lens of Cassandra, because that's kind of my chosen home right now. But I do think it's worth considering. And I do think it's going to matter more and more as we move from silos to fabrics for our apps and our data. All right, cool. Don't clap again when I say thanks. Thanks. Already got that. And I think that's the end of our day. So I wonder when we go outside if it'll be 72 degrees and sunny. I sent my wife the dark sky image of the weekly forecast. Well, it was 72 degrees every day. She was not amused. She is in the swamp of Central Virginia. You guys were talking about that earlier. I remember the first time I went to like North Dakota, and it was 85 degrees with no humidity. And the idea of being in 85 degrees without an air conditioner is something a Virginia boy never would have understood, but it turns out it's not the heat. It's the humidity.
I was in Reno last year, and I just mentioned I had a bad car accident, and I started seeing divots in my leg because the humidity was 12%. It was like it was on the wrong side. My contact started to stick. It was like on the wrong side of the humidity scale. So.
Hi, I'm Rex, by the way.
Nice to meet you, Rex. I'm Taurus.
Thank you, Dave.
Yeah.
I never know
I
if
just
I should
started
put on my
in
mad
AWS
scientist jacket
Oh,
and just read.
how everybody else
I work for.
I'll take one or two people nodding. I'm
We're
happy
in
with that.
the strategy
I'm
and
old
marketing
enough to
group,
know
which is we go alongside.
Thank you.
I wasn't around when Brunel
Nifty's
used to
awesome.
hit blocks.
No, neither was
I
I.
do not think she's here.
I always thought, like,
I think she'll
but
be
the
in
reference to me really
Open source.
is civilization.
I think that's for next.
Because in the civilization video game,
Mechanization is
replaceable parts, I think it was.
manufacturing
Yeah.
of parts by
I still haven't.
Yep.
made my
Henry
reservations
Ford's
yet.
Yep.
assembly line.
And we talk about Ford and we talk about Eli Whitney, but like,
Oh, hold on, I'm sorry.
when I looked at the history, the Brunel thing was amazing.
So we have, I work for Mercury Insurance.
What's that?
I'll talk to you later.
Yeah, are you around? Oh, I'm not doing anything today. I'm going to the hotel pool and just being an idiot.
Okay.
When's your session
I went to the
tomorrow?
pool, it was hot.
Yeah,
Tomorrow, around this time.
okay. Cool. I will at least be in the front row of the audience. Hopefully.
Get some tomatoes and. I'll just be another minute.
Oh, no.
I work for Mercury Insurance. We have a small data stacks
Yeah.
deployment. We've had the same systems for years. We are about to just replace them with other single, new hardware, same thing. We're not really growing in our Cassandra usage, fortunately. The question is, we just bought some stuff. The question is, how do I put this into my Kubernetes cluster instead of going back to the same single?
It depends on what you're using in data stacks.
Also, our Kubernetes clusters are on-prem, as would be this current deployment.
Are you using search or analytics? Or
I
just
don't
pure
believe-
Cassandra?
I believe we're just using pure Cassandra. I think they have some.
Hit me up. There should be contact information, but it's matt.overstreet@datastacks.com. There's a little bit of a bridge between open source and DSE, but I think the Cassandra guys were telling me that we can run the DSE version and there's just a little bit of a headache if you're going out
Okay.
of it. Also, let me know, because we're trying to build an argument that we basically, in a future update, need to go just put blocks underneath all the Cassandra installs in the world and sneak Kubernetes underneath them as a control plane, even if we
okay.
don't advertise
Okay, yeah.
to the customers. Because we just,
you're gonna just give me these hardware boxes. It'll put Kubernetes on them, and it'll put Cassandra.
literally, you upgrade. I don't know if this is going to happen in DSE 7, but literally you upgrade to DSE 7, and part of the upgrade is, I can't think of the name of it, kubelet or something along those lines that just sort of lives
Kubelet
underneath
is
the
thing
new
that lives on
executable.
Each node.
And we can manage it that way, because then we just stop writing some of that code that
Right.
Kubernetes is going to do for us. Like, why reinvent the wheel on that?
Okay.
It's just Matt Overstreet.
Two T's?
Yep, MATT. I'll save in here. Take this out of your way and you're all good.
It worked good?
Yeah, it was great. Unstoppable capitalist. That is certainly not me.
I follow you there.
Awesome. I don't think I should have turned on that.
Is this yours? No, it was this little piece. No.
I don't know whose that
Oh, that's mine.
Oh,
I
is
need
it?
that, bro. Okay, because we're just like wondering, because I know this is. Testing, hello.
I'm thinking that when my kid, who's 11 now, gets to 16, we need to just start like Ubering him places so we don't have to drive. I thought that would happen by the time he hit 16, where he just had like a Uber subscription and we would have burned X amount of money to get around.
Or you just, make sure you have a driver's license.
Driving is overrated. It's gonna be bespoke.
My entire goal is to get as many licenses and certifications as possible before getting a license. Currently, I'm forklift certified for a road.
That's hilarious. There's a bunch of nautical too. Hey Jeff, were you saying something?
So I've been playing with this technology recently. Do you mind? Because I hate this thing.
I don't know.
Okay.
Although I've made it this far,
I haven't gotten either.
and gone to the number of people that haven't gotten it
Yeah, that's really
is going down. It's like the end of the zombie
Yeah.
apocalypse. Like, I have a list of friends who haven't dealt with it, and it gets smaller every day.
So, all right, and this is like, whatever.
Yeah.
So, I've been working on this technology and we're thinking about bringing it into trading mesh. So, our initiative that we have with trading mesh, especially for like onboarding open source developers, people that want to contribute to the project, is getting them started. And like, we have this huge, you have to install Kubernetes, you have to know Kubernetes does it. So basically, what I'm trying to do right now is replace our transport layer for the events with Leaves, Knative, and Parker, so a couple of different ones that I'm looking at, but the most interesting one right now is a project called Data. Are you familiar?
I'm not, so there's a level that I start to fall off, but if you're curious, I'll actually hook you up with the guy in the Cassandra team
Yeah.
who constantly gives me new things to go research.
Okay.
Who's actually doing
Well, I was
this.
just going to look at your code and then bounce it off you if it made sense, but what's cool about it is basically you don't have any networking requirements other than you have to have an outboard access to the internet, and you give it a wallet address, not an IP address, and it connects through the nodes. So what's cool is that you could have that Cassandra where it connects all those nodes like out of the box where you don't have to configure it.
What we need to do, yes, what we need to do, and you see this happen in Astra a little bit in our as a service, we actually tore the monolith up and started to take features out of it, so that some of the functions of managing data files are their own pods now, like compaction and cleanup, and the other thing that we really want to do is start to back off of this idea that the coordinators need the direct IP address, IP communication, and that they need to maintain cluster state too through this conflict protocol. So we're moving as much as we can